So, I'll mention first of all something that I had a couple of you try that I really love that just doesn't work in this problem. I had a couple of you try to do number one graphically. I love doing things graphically. The problem is, while I know exactly how to graph the sine of 2x minus pi over 3, none of the points that I'm going to draw on that sine curve are going to be points that have a y value of a half. I can see them, but I won't know what the x value is. This is not a problem I can do graphically. So, algebraically, we've talked about anytime, and there are not a lot of things in trig I can tell you always or anytime you see this. If I have the sine, the cosine, the tangent, the secant of something that's not plain old x, I'm going to think something much simpler. I know this is not sine times 2x minus pi over 3. This is some angle. And what I am trying to do in order to solve is to figure out, okay, the sine of what angle is a half, and what would I plug in for x that would create that angle? Now, some of you seem to like it helps you to actually write that as an angle. So you put something in a substitution in place where you're letting theta be 2x minus pi over 3. I would say, by all means, please, if that visual representation helps you, please do that. But what's much more important is you understand all I need to know is what angle do I take the sine of and get a half. Patrick, tell me an angle I take the sine of and get a half. Okay, one angle would be pi over 6. On our unit circle, that's up here in the first quadrant, if you take the sine of pi over 6, you are going to get a half. That's my angle. That angle is equal to pi over 6. Now, that's not solved for x. I don't know what x is, but it is what I take the sine of and get a half. But I need to put together full knowledge. And what some of you are finding, unfortunately, is that sometimes the lack of not having done all my homework along the way. And now that we're solving equations and we are putting a ton of trig together, I find myself missing little details. Like, oh, wait a minute. Yes, I could have wrapped around this circle pi over 6 units. But I also could have come around more than once. Or I could have come in a negative direction. And all of those end up coterminal at that same location, and the sine of that is still a half. I could add or subtract, so we'll use an integer value, full revolutions around the unit circle. Now, this is the one advantage. If you thought of this graphically, it probably is an advantage graphically. While I can't solve this graphically, when I think about where sine is equal to a half, okay, that looks like about a half, and that looks like about a half. There's an infinite number of those, and they are one full period apart. But pi over 6 is not the only thing I take the sine of and get a half. Abigail, what else do I take the sine of and get a half? Right, so over in the second quadrant, that's where sine's going to be positive. My angle also might be 5 pi over 6. So what I take the sine of might be 5 pi over 6 plus my multiples of pi. Now, my angle is not theta, and if you call this theta, that's just fine. My angle is actually 2x minus pi over 3. That's what I'm going to solve to figure out what do I plug in for x so that this angle turns out to be pi over 6, or so that this angle turns out to be 5 pi over 6. Yes, sir. Well, okay, so think unit circle. I'm here at 5 pi over 6. Could you wrap all the way around that circle and still be the sine be a half? Yes, so I still need to add that period, right? Whether I'm here on my graph, and I'm adding the period to get out here or subtracting the period to come back here, or I'm doing the same thing here. I mean, it's going to repeat itself no matter which angle we're looking at. All right? Now, other questions to that point before we finish solving for x? Okay, now, if you could get to here, to this spot, you've done with trig. Everything else is algebra. It's exactly like, go back to middle school, 2x minus 5 is equal to 7. I mean, it's exactly the same thing. Right? Yes, it's not subtracting 5, but it's the same process. I want to isolate x and get it by itself. So I'm going to take and add pi over 3 to both sides, or 2 pi over 6. I do have to deal with common denominators. So 2x is 3 pi over 6. I know that's pi over 2, but I want to make sure we understand where that's coming from. Plus 2k pi. And then my job is to solve for x. Hannah, how do I get x there by itself? I divide by 2. Or if you would prefer, because you have fractions, if you'd prefer to multiply both sides by a half, that's okay as well. 2x times a half is just x. 3 pi over 6 or pi over 2 times a half is pi over 4. 2k pi times a half is k pi. This should not come as a surprise what this turned out to be. Because if I drew this graph, the period would have this horizontal compression of a half. The period would be pi. That's why we're adding pi. Even though I didn't solve it graphically, that's why we're adding pi. It's the period of this graph. Now, I prefer, because it helps me when I come to the end, I like to write that period with a common denominator. So x is pi over 4 plus 4 pi over 4. That helps me to list these solutions between 0 and 2 pi. It's not a requirement. If you don't do it and you correctly list those, that's just fine. But that is a major help for me when we come down to write our answers. But before we write our answers, let's figure out what else x could be. We'll add pi over 3 to both sides, or 2 pi over 6. So 2x is 7 pi over 6 plus 2k pi. And then again, as Hannah pointed out, we can divide by 2. We can multiply everything by a half. We're going to get 7 pi over 12 plus multiples of pi. Now, let me pause there before we finish up listing our solutions between 0 and 2 pi. Are there any questions to there? Whether you're here or you're at home? Yes, sir. Okay, so I added pi over 3 to both sides. But adding pi over 3 is the same as adding 2 pi over 6. And that's where the 7 pi over 6 comes from. Are there any other questions there? Okay. If this problem had just said solve, I'm done. That's it. That's all there is to it. It didn't. It said list the solutions between 0 and 2 pi. Okay, so x is equal to. So I'm going to start with this first group. I know pi over 4 is a solution. I'm going to add my period. That's why I find it helpful to have a common denominator. 5 pi over 4 is a solution. I'm going to add my period, and 9 pi over 4 is a solution. 13 pi over 4 is a solution. And I'm going to list all those until I get to something bigger than 2 pi. Well, 9 pi over 4 is larger than 2 pi. So while 9 pi over 4 is a solution to this equation, it doesn't fit between 0 and 2 pi. I have a solution at 7 pi over 12. I'm going to add my period of pi, or 12 pi over 12. And I'm going to have 19 pi over 12. I'm going to add that period. I'm going to have 31 pi over 12. That's more than 2 pi. Now, I don't have it in this problem, but let me make you a major warning. it is not uncommon for my students to forget, not only can we add the period, continue to go counterclockwise or go to the right on our graph, sometimes I actually might need to subtract the period. This is also a solution to this equation. Take 7 pi over 12, subtract my period. That is a solution. Now, it's not between 0 and 2 pi. But if this had started, say, at 13 pi over 12, 1 pi over 12 would have been a solution between 0 and 2 pi. Right? And so I have to be careful with that to remember I can add that period or subtract that period. Now, are there any questions in number 1? Okay, we're at least momentarily going to skip number 2. Let's go over to number 3. Because number 3 has very, very different skills. Now, number 3, I just have thetas. Okay, so I don't have to think something simpler. But I can't tell you what I'm going to plug in for theta, find the secant of it, square that answer, multiply by the tangent of that angle, and it equal to 2 times the tangent of that angle. I just don't know that answer. What you need to be looking for as you're working in homework, as we're working in class, is you want to be looking for, okay, what helps me know how to start this problem? Well, what helps me know how to start this problem is that I recognize, wait a minute, both of these sides of this have tangents. So I'm going to put all that together. Secant squared theta, tangent theta, minus 2 tangent theta is equal to 0. Now, while it's not always that when I solve a trig equation, I want it equal to 0, when I see squares, the first thing I'm going to try is, this looks like a quadratic. And my favorite way to solve a quadratic is to factor. Well, I can factor that. Tangent of theta times secant squared theta minus 2 is equal to 0. Notice so far all we've done is a little bit of algebra skills. All right, so, well, I got 2 things multiplied together and their answer is 0. One of those 2 things has to be 0. Either tangents equal to 0 or secant squared minus 2 is equal to 0. The first piece I'm just ready to solve. That's think of the unit circle. What do I take the tangent of and get 0? Okay, well, tangents equal to 0 when I'm at 0. When I'm at pi, when I'm at 2 pi, when I'm at negative pi. Oh, so 0 plus, there's my period of tangent. I didn't draw the graph of tangent, but I know what its period is. Or I could just write 0 plus k pi. It's any multiple of pi. Doesn't matter what you plug in. If you plug in pi, the tangent of pi is 0 times, well, secant squared, that's going to be 0. 2 times the tangent of pi is 2 times 0. It's going to work. Well, it's going to work as long as secant is defined. And secant is defined at pi. Right? It's 0. Right? So 0 times this secant of pi, which is, of course, is negative 1. 0 times that squared is still going to be 0. Now, over here, you got 2 options. And I'm going to show you both. I'm going to show you first my preferred option. Okay. This is a quadratic. I got stuff squared. And my favorite way to solve a quadratic is to factor. And before you say, Mr. Epling, you can't factor that. Oh, yes, I can. This is a difference of squares. It's not a difference of squares you would have done in Algebra 2. Now, I don't have room beside that, so I'm going to have to come down below it. Because in Algebra 2, you only factored with integers. You didn't factor with irrational numbers. And that's okay. I don't have to do it this way. That's why we'll look at a second option. But factoring is my favorite option when I'm going to solve a quadratic. So I'm always going to attempt it. And I have the same thing. I got two things multiplied together. One of those two things, I'm going to space out so I have a little more room. One of those things is going to equal 0. Might be both of them, but at least one of them is going to equal 0. So secant of theta minus root 2 is going to equal 0, or secant is going to equal root 2. Or I could have that secant of theta plus root 2 is equal to 0. So secant is equal to negative root 2. Now, either way, I'm thinking about the same kinds of things on my unit circle. I'm just thinking different quadrants. But this requires I know my unit circle. And I know, hey, Mr. Evans has been giving me 10 problems every day for the last few weeks. The secant of pi over 4, the secant of pi over 6, the tangent of pi over 3, so that I'm continuing to work on those values on the unit circle. But I got to be honest. Don't tell Mr. Epling I haven't been doing those. I don't have any clue what that is. Okay. I'll do it another way. If secant is root 2, what else do you know? If you know secant, what else do you know with no work? I know cosine. What would cosine be? It'd be 1 over root 2. You say, Mr. Epling, that doesn't help me any. I don't know what that is on the unit circle. Yes, you do. Because 1 over root 2, if we simplify it, is root 2 over 2. In trig, if you'll be willing to, I'm going to work, even if at times I haven't put in the work I'm supposed to and I'm just not willing to give up, I got multiple options. I'm going to be in the first quadrant. I'm going to be in the fourth quadrant. Theta is pi over 4. Or I could wrap all the way around my circle either direction. Theta is 7 pi over 4. Or if you would prefer, you could write that negative pi over 4. That's the same location on our unit circle. So over here when secant's negative root 2, we're just in the second and third quadrants. So theta is equal to 3 pi over 4 or 5 pi over 4. Now that's not our final answer. Those are all our solutions, but let's make sure right there we don't have any questions. Are there any questions at all solving that? Okay. Then I have to list my solutions between 0 and 2 pi. So theta is pi over 4. If I add the period, that's 2 pi. That's 8 pi over 4. That would be 9 pi over 4. That's more than 2 pi. So I have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are our 4 solutions between 0 and 2 pi. And it doesn't matter what order you write those in. They don't have to be in ascending order, as long as we have those 4 solutions. Now, are there any questions there? Now, I told you we would look at that secant squared in 2 different ways. So if you're like, I would have never thought, or I don't like factoring with square roots, it's not a big deal. You have other options. You can just do some algebra. I want to get theta by itself, so I'm going to add 2 to both sides. I need to get rid of something squared, so I'm going to take the square root of both sides. I am going to be very careful that the square root of secant squared is not secant. It is the absolute value of secant. And in order to solve this, I got to get rid of absolute value. Well, that's not like subtracting 2 and I can just add 2. I've got to know something that's equivalent to so I can replace it. I need to know the piecewise, and I'm going to have to write that piecewise. The absolute value of secant is secant of theta. I'm not going to do anything to this. if I'm already positive. But if it just so happens that I have a negative, I'm going to multiply that negative by -1. So I make it be positive because absolute value is always positive. And then you can choose either one of those to put an equal to on. It won't matter. The opposite of 0 is 0, or 0 is 0. And I have secants equal to √2. Or the opposite of secant is equal to √2. Or secant's equal to -√2. Now, I don't care which one you choose. It makes no difference to me. I'll just be honest. I prefer to not have to do all the absolute value stuff in piecewise, which is why I would have factored it. But there's nothing wrong with this. Nothing at all. Now, sometimes one of the hard things for students about solving trig equations is that's not the only way to do this problem. I'm going to use Madeline back there as an example. Madeline recognized, hey, I know an identity for this. Secant squared is 1 plus tangent squared. So she said, look, I got 1 plus tangent squared times tangent, and I know how to multiply that out. Now, she still ended up factoring, but just a little bit differently. Multiple ways we can work that problem. Doesn't matter which one you choose, as long as you can choose it, come down to the end, and get things that work. Well, how do I know? I mean, I got pi over 4 and 3 pi over 4. How do I know these actually are things that work? How do I know that's right? Because on my test on Monday, my quiz on Monday, Mr. Epling is not going to give me the solution so I can check as I go. How do I know if pi over 4 is correct? I just plug it back in and check. If you want to know, okay, secant squared of theta, well, that'd be secant squared of pi over 4 times the tangent of pi over 4 is equal to 2 times the tangent of pi over 4. Now, be very, very careful here to recognize, to know what that notation means. That means find the secant of pi over 4, and whatever that answer is, square it. The tangent of pi over 4 is 1, and so we have the secant of pi over 4, which is √2, squared times 1 equals 2. And sure enough, 2 times 1 is 2. Pi over 4 worked. Any questions there in problem number 3? Please, please, please be some questions. Please? Somebody? Thank you. I haven't finished this problem. There's more than 4 answers. Yes, there are all of these. Oh yeah, I can't forget I had all of these solutions too. So for example, 0 is a solution. If I add pi to that, pi is a solution. If I add pi to that, 2 pi is a solution. Oh, wait a minute. That's not between 0 and 2 pi. Non-inclusive. There are a total of 6 solutions to this equation. And lots of times when we are solving trig equations, we got a lot of work. We don't want to lose sight to make sure we put all of our solutions together. Now, are there any questions? Okay. Since problem number 1 and 2 for some of you went less than perfectly, we'll be positive. We've helped with number 1. I want you to go try number 2. If you've already got number 2, you got the right answer, take a deep breath for just a minute. Okay. But that way, all right, I had trouble. I don't know at home because I can't see your work. Right. But Much, 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 much better. And I want you to notice something. That was with working how many problems? One. Well, one like that. Granted, we worked two, but one like that. If you put in a little bit of practice, wait a minute. This looks like I know how to do that problem. Okay? You can do this. All right. So I've got the cosine of some angle is equal to root 2 over 2. I need to know what that angle is. All right, Hannah, tell me one thing we take the cosine of and get root 2 over 2. Be pi over 4. That angle is equal to pi over 4. Now, I could wrap around my unit circle one direction or the other, so I better add my period. Is there anything else I take the cosine of and I get root 2 over 2? What is it, Adam? Okay, 7 pi over 4 or negative pi over 4, whichever way you want to write it. It makes no difference. That's our angle. But our angle is 4x minus pi over 4. What we're taking the cosine of is not theta. It's not just some angle. It's the angle 4x minus pi over 4. And now I'm ready for algebra. I'm done with all the trig. I'm ready for some algebra. I'm going to add pi over 4 to both sides. So we'll get 2 pi over 4 or pi over 2. And then we're going to divide everything by 4 or multiply by 1/4. And x is equal to pi over 8, 2 pi over 16, plus k pi divided by 2. Or 1/2 k pi as some of you wrote that. This should not come as a surprise. Hey, if I drew this graph, Mr. Evelyn didn't tell me to graph it, but the period would have been horizontal compression of 1/4. It would have been pi over 2. Okay? It's not some random number that's just showing up here. Same thing over here on the other side. We add pi over 4 to both sides. We get 2 pi, 8 pi over 4. Or 0, same angle. Divide everything by 4. We get pi over 2 plus k pi over 4. No, k pi over 2, excuse me. Our period. Now let me stop there. We haven't listed our solutions, but are we comfortable to that point? Okay, now I'm going to list my solutions between 0 and 2 pi. This is when I would prefer to think of this as 4 pi over 8. That is pi over 2. So that I have a common denominator. It makes things a little quicker and faster. So pi over 8 is a solution. 5 pi over 8 is a solution. I'm going to add my period. I'm going to keep adding my period. 9 pi over 8. 13 pi over 8. 17 pi over 8. And I'm going to go till I get to 2 pi. So it is helpful to think of 2 pi in terms of eighths. That's 16 eighths. I don't want to go any farther. So I so far have 4 solutions. I got some more over here. All right, I got pi over 2 is a solution. I could add my period and I'd get 2 pi over 2 or pi. I could add my period and I'd get 3 pi over 2. Now, if I add my period again, I get 2 pi, and that's not between 0 and 2 pi. Now, this would be a good example. If this had been on your formative yesterday, Mr. Epling just got a 0. Because it's going to count that whole thing wrong. Although I've done a lot right. In fact, I've done almost everything right. I don't have all the solutions. Anybody know what I didn't get? I didn't get 0. Remember, k is an integer. It could be positive 1, positive 2, positive. Oh, yeah, I could also go backwards. It could be negative 1, negative 2. Pi over 2 minus pi over 2 is 0. 0 is a solution to this. Graphically, I'm moving left, right? On my graph, I'm going back a period instead of forward a period. There are a total of 8 solutions. Okay, good question. Why can I put 0 but not 2 pi? 2 pi is a solution to this. However, I got to go back to your opener page. The directions said find the solutions between 0 and 2 pi, and there's a parentheses here. It is not included. That's why. 2 pi is a solution. I just can't include it in my interval. Okay? Bracket is included, parentheses not included. Okay? Now, not to pick on you, that's probably a good question to have asked like a week ago when we saw that for the first time. But we're getting it cleaned up. Any questions at all here? Okay, I want to give you one little hint. I knew this problem had 8 solutions before I ever started. Mr. Irving, how did you know that? Okay. I'm telling you, if you can learn for yourself to think about pictures, it is so helpful. All right, so here's my little cosine curve. And I'm going to draw one period out to 2 pi units. Now, I'm not going to act like I know exactly where root 2 over 2 is. But I know it's a positive y value. Cosine equal to root 2 over 2 would have had 2 solutions. What does that do to your graph? What does that 4 do to my graph? It horizontally compresses it by a 4th. So now, how many full ways are you going to draw in 2 pi units? I'm going to draw 4 of those. My frequency is 4. Oh, so if one of them had 2 solutions, 4 of them are going to have 8 solutions. Okay? Because I've horizontally compressed this. There's no way I'll accurately draw 4 of those without labeling everything. Yeah. Okay, yeah, I know. They're not equally spaced apart. But we'll pretend. Okay? That's what's going on. Okay? Any questions at all there with your opener? Okay. Let's take a look at your homework from last night. Ton of information packed into this one problem. This is number 92 from your homework. Okay, so let me tell you what jumps out at me as soon as I look at this problem. I don't know how to solve it. Because I've got 2 trig functions. Right? So the first thing that jumps out at me is, I don't like 2 trig functions. I'd like to have only one. That screams, I need identities. The problem is, I don't have any identities that will allow me to rewrite cosine in terms of sine. Or sine in terms of cosine. What's the closest I can come that we have an identity that has both sines and cosines? Yeah, I do know sine squared plus cosine squared is equal to 1. That's the best I can. I don't have squareds. But that gives me an idea for something I might want to try in this problem. I'd like to have squares. It's an equation. I can do anything I want to both sides. Now, because I'm going to square, I'm going to think of this 2 ways. I also would rather not have that square root, so I'm going to get the square root by itself. It is not incorrect to not get the square root by itself, but that's what I would rather square. Simply because if I square sine plus cosine and I multiply that by itself, I do get sine squareds. I do get cosine squareds, but I get that middle term, which is sines times cosines. I still don't know how to deal with that. So this way I avoid that. But as soon as I write that down on my paper, I can hear in my head a little alarm going off. Uh-oh, uh-oh, uh-oh. You better watch out. You just squared both sides. You might have extraneous solutions. I don't know. I haven't solved yet. But I'm immediately concerned. Anytime I square both sides. Because I took an expression that might have been negative. It is negative at times. The square root of 3 times the sine of theta is sometimes negative. And when I squared it, 3 sine squared is never negative. So I might have some things that I solve that don't work. Now, do be careful, and if you need to help you make sure you get this squaring right, squaring does not mean square 1 and get 1, square cosine and get cosine squared. It means multiply this by itself. And I have all kinds of students who, if they'll write that out, they don't mess up the multiplication. But when they don't write it out, they get in a hurry. 1 minus 2 cosine theta plus cosine squared theta. Now, there are two things that I'm thinking about when I get to here. Number one is I see those squareds. And I am thinking quadratic, quadratic, quadratic. I'd like to do this by factoring. But number two, I still have two different trig functions. I still have sine squareds and I still have cosine squareds. But now I have a way to rewrite. I know what sine squared is equal to. It's equal to 1 minus cosine squared. Now, why did I do sine squared was 1 minus cosine squared instead of cosine squared was 1 minus sine squared? Why write sine in terms of cosine instead of cosines in terms of sines? Right, because I had another cosine in the problem. So I want everything in terms of cosines. So 3 minus 3 cosine squared theta is equal to 1 minus 2 cosine of theta plus cosine squared theta. I recognize the squares. I'm thinking quadratic. I'm thinking I want to factor. So I'm going to make this equal 0. I'm going to add 3 cosine squared to both sides, and I'm going to get 4 cosine squared. I'm going to subtract 3 from both sides. So I have 4 cosine squared theta minus 2 cosine theta minus 2, and that's all equal to 0. Now, while it's probably not a big deal in this particular problem, anytime I have a quadratic that I can simplify, I'm going to. I don't think there's anything on that watch that's that important. I'm going to divide both sides by 2. I don't have to. I could solve it the way it is. And because these are small numbers, you're probably not going to have any trouble. But I keep myself in that habit, so if the numbers are a little more complicated, I don't have any trouble solving. And fortunately, I do have something in this case that will factor. If it didn't, I'd have to solve with completing the square or quadratic formula, but I can factor. 2 cosine theta times cosine theta will give us 2 cosine squared theta. 1 times 1 is going to give us 1, and 1's going to need to be positive and 1 negative. We need minus 2 cosine theta and plus 1 to get minus cosine theta in the middle. If you haven't figured it out by now, factoring is a huge skill when it comes to solving. Lots and lots of problems that you've worked on. You had several in your formative yesterday where factoring helped us to solve. And not uncommon to have to use the Pythagorean identity to rewrite in terms of one trig function. So we have cosine is equal to negative 1/2. We'll subtract 1 and divide by 2. Or cosine is equal to 1. So now I'm ready to think unit circle. Okay, well, cosine is equal to 1 at 0, at 2 pi, at 4 pi, so on and so forth. Cosine is equal to negative 1/2. We're in the second and in the third quadrants. That's at 2 pi over 3 and at 4 pi over 3. And if I'm remembering correctly here, we weren't finding solutions between 0 and 2 pi. We were just finding all the solutions. Now I'm going to pause there. Are there any questions in using our Pythagorean identity, factoring, or solving what we end up with? Yes, sir. Because this is not 1 minus cosine squared. This is 1 minus cosine that quantity squared. That's 1 minus cosine times 1 minus cosine. It's not only the cosine that's being squared there. Any other questions? Okay, here's the most common mistake students will make, because this was a long problem. Whew, I am so glad to have finished that. Look at me, I did such a beautiful job. The problem is you're not done. That's why those bells and whistles in my head were so important. I might have some of those solutions I just found that don't work. And there's only one way to know if they work or not. I have to plug them back in and check. Have to. So I'm going to check. No, I should check. I could check. I must check. So we've got the square root of 3 times the sine of theta. It doesn't matter which one we start with. I'm going to start with 2 pi over 3. Plus cosine of theta. Y'all stop me if I don't remember this equation perfectly. It's equal to 1, right? Okay. Not I should do this. I have to do this. So the sine of 2 pi over 3. Well, that's root 3 over 2. The cosine of 2 pi over 3. Well, that's a half. Does 3 halves plus 1 half equal 1? No, this doesn't work. These are not solutions. I didn't do anything wrong. I didn't make a mistake in my algebra. All right, let's try our next one. You know, it might be none of these work. You'd be pretty mad at Mr. Epling because you did all this work and you didn't have any solutions. But it's possible. So we check our next solution. Well, really our next set of solutions. All right, the sine of 4 pi over 3. Oh, wait a minute. Wait a minute. Let's back up. Y'all didn't stop, Mr. Epling. You should have. What's the cosine of 2 pi over 3? Yes, negative half. I'm sorry. Does it work? Yes, it does work. That'd be one of those simple little examples. If you did it on Math Excel, you got a 0, but you knew what you were doing. Okay, let's come back over here. So we have root 3. The sine of 4 pi over 3, that's negative root 3 over 2. The cosine of 4 pi over 3 is negative 1 half. So negative 3 halves minus 1 half. Does that equal 1? It doesn't. That doesn't work. All right, I got to check my last one. This is the easiest one to check. The square root of 3 times the sine of 0 plus the cosine of 0 is supposed to equal 1. Well, the sine of 0 is 0. So the square root of 3 times 0. The cosine of 0 is 1. And sure enough, 0 plus 1 does equal 1. That works. So now I'm ready to write my final answer. Theta is 2 pi over 3 plus 2k pi. Or it's 0 plus 2k pi. We could just write as 2k pi. Now, are there any questions at all there in that problem? Because there's a lot going on there. Look at all that good algebra you get to review here. You make your Algebra 2 teacher so proud. Okay, now this is not why I said this was really important to write down. This is not why I like this problem. That's not how I did it at all. The reason I like this problem is there's a very, very different way. I think of it as a creative way to do this problem. Now, I'm going to tell you up front, I probably would not expect that you thought of this when you did this problem or the first one of this type. That's why I'm showing it to you. Okay. I still don't know how to rewrite all those things. But I actually have two identities that put sine and cosine together. One is sine squared plus cosine squared. I'm going to take this problem and I'm going to multiply everything by half. So root 3 over 2 times the sine of theta plus 1/2 the cosine of theta is equal to a half. Now, is that the same problem we started with? Sure, right? I did something to both sides. Okay. Well, I chose a half because, hey, that gives me values I know on the unit circle. I recognize root 3 over 2, that's the cosine of pi over 6. So I'm going to call this the cosine of pi over 6 times the sine of theta. And a half, well, that's the sine of pi over 6 times the cosine of theta. And that's all equal to half. Now, some of you aren't writing this. I'd strongly suggest it. It is a whole lot easier way to do this problem. Well, it's a lot shorter. Maybe easier isn't the right word. All right. Now comes the moment of truth. Have I put in my hard work and I know what that is. Anybody recognize that? I failed you as a trig teacher. Maybe if I just turn it around, it'll help. Sine of theta, cosine of pi over 6. Yeah, it is sine, cosine, cosine, sine. That's the second identity I have that puts sine and cosines together. And now look at here. That's the sine of theta plus pi over 6. Mr. Epling, we just did some of those in our opener. I've gotten much better at that today. I can solve that. Now, important question for you. Have I squared both sides? Do I have to worry about extraneous solutions? Don't have a possibility of them. Now, I might have domain issues. I don't because this is sine and cosine. But I'm ready to solve. What do I take the sine of and get a half? Well, that'd be pi over 6. It'd also be 5 pi over 6. My angle is theta plus pi over 6. And I'm just going to solve. If I subtract pi over 6 from both sides, I get 0. Plus 2k pi, or 2k pi. If I subtract pi over 6 from both sides, I get 4 pi over 6, or 2 pi over 3. Now, I'm going to tell you right up front, I'm not going to give you a problem you have to do that skill with. But you might find, I didn't really like that whole squaring both sides and then having to factor and then having to solve and then having to plug in and check. And by being a little creative, I don't have to do all that. Okay, so we had one more question from your homework. That's problem number 4. So let's look at number 4. That'll be the last one we look at today. So 1 plus 2 cosine x. Number 4 is primarily an algebra-based problem. Divided by 1 minus cosine x is equal to 4. Now, I will tell you, because I have division in this problem, the first thing I'm worried about is making sure that I don't end up with a solution that doesn't much look like a C. That 1 minus cosine, it shouldn't equal 0. So I am concerned there about domain. But the first thing I do just about any time I have fractions is I don't like fractions. So I'm going to get rid of them. And I'm going to multiply both sides by that denominator so I can get rid of those fractions. So 1, that's going to look like a negative. 1 plus 2 cosine x is 4 minus 4 cosine x. And so I'm going to put like terms together. I'm going to add 4 cosine x to both sides. So 1 plus 6 cosine x is equal to 4. And then subtract 1 from both sides, so I can isolate the trig function. 6 cosine x is equal to 3. And then I need to get cosine by itself, so divide everything by 6. And the cosine of x is equal to 1/2. And I'm ready to think about my unit circle. What do I take the cosine of and get 1/2? That's something in the first quadrant and in the fourth quadrant. That's pi over 3. And it's 5 pi over 3, or negative pi over 3. Now my directions here were to give me only the solutions between 0 and 2 pi. And so those are just going to be pi over 3 and 5 pi over 3. Don't like fractions, I'm going to get rid of them. Okay, now let me give you all a suggestion. Make sure that I don't have somebody in particular. I don't. Okay. So yesterday you had your little formative that you did on solving trig equations. If you'll come over here under student to results, I won't have results because test student hasn't taken it. You can go back and look at what you did, what I get right, which ones did I get wrong. And if I missed one, it's probably a really good idea for me to try to work that again and get it right. Figure out what did I do that wasn't quite perfect there. Okay? That's over here under your results tab that you will be able to see those. Okay? So I would make that strong suggestion for you. Okay? Tonight you have homework number 7. So for those of you that are here, let me give you a copy of homework number 7. Maybe I'm going to give you a copy of homework number 7. I'm not going to give you a copy of homework number 7 because I have misplaced your copy of homework number 7. But it's in Canvas. Right? It's posted already for you. Right? Tomorrow, for all of you, we're going to do another little formative. Okay? And I'm going to tell you, it's 3 questions. Okay? For those of you that are home, I'll post it in Canvas. We're going to do this tomorrow. I want this to go much better than what yesterday did. So if you need some help, let me know. Okay, I'll be happy to come by and help you. All right, guys, have a great day. If you need some help, I'll be here after school. I'm in here in the morning before school. I'm happy to help you.